Solid metallic cylinder and a solid cone have the same base radius equals to 7 cm and the same vertical height 24 cm. Both the solids are cut vertically into two equal halves along their axis. These halves are joined together along their flat vertical faces to form a unique decoration article such that their semicircular bases align to form a single complete circle at the bottom. If the slant height of the cone is L, calculate the total surface area of the resulting solid. Now, we have been given that there is a solid metallic cylinder and a solid cone which are having both same radius and same height. Now what happens when you take a cylinder and try to cut it into two equal parts? We generally think that if the cylinder is there, the cylinder total surface area is given by the curved surface area and the two bases. Now when you divide this into two parts, it should be equal to half of that whatever the area we got. But what we generally forget is when we cut it into two parts, we are adding another new surface which we can see. You can imagine taking a cylinder like a Coke tin and try to cut it along the height and see if it is a solid cylinder, then you will see that there is a flat surface which is coming. So let us say if this is our cylinder, we are trying to cut this into two equal parts. Cut this into two equal parts. So what you are going to see now is this will be curved surface area, what you can see, and this will be a semicircle and this will be a semicircle, and this part will give you a flat surface, a rectangle you will see there. The rectangle with breadth as 2r, diameter and length equals to height. So this has to be very clear. If you have a cylinder of radius r and h, you try to cut this into two equal parts along the axis, then you will have three surfaces. One will be the curved surface area and you will have two bases, and also in addition to that you will have this flat surface which will be a rectangle cylinder. Now let us take the case where we have the cone. Suppose you have a cone. You try to cut this into two equal parts. Imagine you are taking an ice cream cone and you just cut it along the height. What you are going to see? You will see the CSA, this part of the CSA, half of it will come, and this will be a semicircle which is correct. And here we are going to get a triangular surface. Triangular surface which will come which will be like the base will be the diameter and height will be the height. So that triangle will come like this. This is H and this is R. This triangular face will be there. Now what happens when you divide this into two equal parts, divide this into two equal parts and join them with each other? When you join them with each other, what we will have is a diagram something like this. I hope you can see this diagram. We have half of the cylinder and we have half of the cone. So what will be the total surface area of this? Let's write down. That will be, the first part will be CSA of cone. That will be half of CSA of cone plus half CSA of cylinder. That will take care of the curved surface area part. Then coming to the bases, now we have been told that the cone and cylinder after cutting into half are joined such that they form a complete circle. That means the base area will be, one side will be area of circle, this side it will be area of circle and here it will be area of half circle or area of semicircle. And the third surface area, what we are going to see is that this rectangle, whatever we discussed earlier, the rectangle earlier, that rectangle is covered by the cone flat surface now. That means this part is covered. This part is covered. So only we can see the remaining part, whichever is there in the black color. So that will be nothing but flat surface area of cylinder minus flat surface area of cone. Now let's try to put the formula here so that we can substitute the values. Half CSA of cone, that is pi r L divided by 2 plus half CSA of cylinder 2 pi r h by 2, that is pi r h. Area of the circle pi r square. Area of semicircle half pi r square. Flat surface area of the cylinder, that is nothing but length into breadth. Length is 2r. Breadth is 2r and length is h, 2rh, minus flat surface area of cone. We know that if you have a triangle and a rectangle on the same base and between the same parallel lines, then the area of the triangle will be half of the area of the rectangle. So this guy will be RH. So this is coming as RH at the end. Now let's combine all of this and try to get the surface area. So let's go back and write down that what we will have now. They are asking that what will be the total surface area of the resulting solid. For that we will write down what we got earlier. Half of CSA of cone, that is pi r L by 2, plus half of CSA of cylinder, that is pi r h, plus, now this base is pi r square at the bottom and the top is half pi r square. So we'll write down together is 3 by 2 pi r square, plus coming to the flat surface areas, there you have a rectangle, here we have a triangle. The triangle is covering half of the rectangle if you can visualize it. So left out is half of the triangle, half of the rectangle area is still visible to us. That we can write it down. So that will be nothing but R into H, because 2RH minus RH. Now let's substitute the values here. We have R equals to 7, H equals to 24. We can calculate slant height. They said L it is. So that will be square root of R square plus H square. That is 7 square plus 24 square. Pythagorean triplet it is. So it will give you 25. So we have L equals to 25, R is 7, H is 24 and pi equals to 22 by 7. Now let us calculate these values. 22 by 7 into R by 2, 7 by 2 into 25 plus 22 by 7 into 7 into H is 24 plus 3 by 2 into 22 by 7 into 7 square plus R into H, that is 7 into 24. Let us simplify that. 7 will go, 2 will go, 11 times 11 25s are 275 plus 7 will cancel, 22 into 24 is 528 plus 7 square will go 7 times, 2 will go 11 times, 3 11s are 33 into 7, 231 plus 168. Now let us add them. 275, 231, 506, 1034, 1202 cm square if you take the radius and height as in centimeters. So what is the hidden trap here is basically if you just take a cylinder and take a cone, just try to cut them into two equal parts and add them. It is not only the curved surface areas what you have to add and the bases. You have to also take care of that flat surface what is created when you cut a solid into two equal parts. Like you take the cylinder, you cut it into two equal parts, you get a rectangle, and where you take a cone and cut it into two equal parts, you get a triangle. That is the part what you have to be careful about. So this is a particular question which was triggered because yesterday one student was asking me that, sir, we have seen the questions where you cut the cylinder into two equal parts. What happens if you cut a cone into two equal parts? Then I just thought this type of question was not available. So why can't we frame a question which will give you understanding what happens when you cut a solid into two equal parts? So the